In 5 seconds.
Hold on. Can you hear me?
Yes, I can hear you.
All right, hold on. Screen sharing. It says I am sharing. Is that possible?
Yes, open large.
Is that all right?
Yes, perfect.
Okay.
3, 2, 1. Go ahead.
All right. Well, I apologize for speaking in English, but that's all I can do, unless you would like me to give this talk in, I don't know, Hungarian or maybe Bulgarian or some other strange language. My name is Seth. I'm at the SETI Institute. So we look for life in space. Amanda has talked a little bit about that. But we're looking for intelligent life in space as well as microbial life in space. So, we might ask, well, why do we think there is any life in space? And of course, Amanda has told you something about that. But this is a photo that was made by the Hubble Space Telescope about, I don't know, a couple of years ago. And this is just a very tiny little bit of the sky. Really, this is so small, you would never normally look at this small bit of sky. But the Hubble Space Telescope made a very long exposure photograph of this patch of the heavens. And you can see all these sort of bright things in the photo. Each of these is a galaxy. Each of these galaxies has several hundred billion, that's 1,000 million, several 100,000 million stars. And some recent results analyzing data from the Kepler Space Telescope has shown that maybe every other star, or 1 in 3 of those stars, has a planet somewhat like the Earth at the right temperature to have oceans and atmospheres. So the number of possible places where we could expect life is just enormous. In our own galaxy, it's on the order of several hundred million, and there are 2 million other galaxies, each with several hundred million possibly inhabited planets. So to say, well, do you think there are aliens out there, is kind of silly, because there's so much opportunity that if there are no aliens out there, then there's something miraculous about Earth. And while you may think that's true, it's probably not true from a scientific point of view. There doesn't seem to be anything terribly special about the Earth. So let's consider where we could find some life. Now, the idea of intelligent life in the universe, that's a very old idea. It goes back many hundreds of years. This is a photo made slightly over 100 years ago of an astronomer by the name of Percival Lowell. He had graduated from Harvard. He was first in his class, a very intelligent guy, also a very wealthy guy. And he could afford to build his own telescope. He didn't have to hope for getting a job at some university or anything like that. He just built his own observatory and named it after himself. So here he is looking through a telescope. In particular, he spent a lot of time looking at Mars. This photo was made, as I say, about 110 years ago. You'll notice that 110 years ago, when you would sit alone in the dark all night looking through a telescope, you would put on a suit. People don't do that anymore. But he thought that he saw canals on Mars. And here are some of the canals that he mapped. This is his own work. And you can see many canals here, supposed canals. In any case, he mapped about 400 of them. It turns out none of them was actually for real. This is a modern photo of Mars. And many of you have seen these things. There's a lot of craters on Mars. There's also this long thing. Whoops. Whoa. Hold on. This long thing here, that's the Mariner Valley. And the distance from here to here is about the same as the distance from New York to Bogota. That's really a very big ditch, but it doesn't seem to be a canal that anybody built. This is not like the Panama Canal or anything else like that. This is a natural phenomenon, probably due to plate tectonics on Mars. But it's big. It's much, much bigger than the Grand Canyon, enormously bigger, 200 times bigger. And if any of the people who are watching this decide that they want to go to Mars next weekend, I would recommend that you try and purchase this property because it's going to become a huge tourist attraction about 100 years from now. But no canals on Mars. Mars kind of looks dead. But maybe it's not entirely dead. This is the south pole of Mars, and this European spacecraft here actually had radar that could look underneath the dirt on Mars. So it looked at these little patches here, and what it found was this. This is what the radar saw. The radar waves came in, they bounced off the surface of Mars. That's what this white line is. But here, about 2 kilometers underneath the surface, you see another reflection. And that reflection, and this has been sort of verified recently, that reflection is probably due to water. There's water under the surface of Mars. Not as ice. There's plenty of ice on Mars, but that may be liquid water. So we don't know what's down there. What we have to do is send a whole bunch of people to Mars, maybe, and have them install a drilling rig here and go down there and suck up that water, take a look in it. There might be microbes there on Mars. Now, I have to point out that many people, and I hear from them every week, they send me emails, think they have found intelligent life on Mars. And they have done so on the basis of looking at rover photos from NASA, and they see things like this. You see that thing on the little circle on the left. Inside there is a little statue of a girl, very much like the statue that's on the waterfront in Copenhagen, Denmark. So they think that's proof of intelligent life on Mars. I think it's proof of a oddly shaped rock. Here's something else they found, a German helmet on Mars from the Second World War. Nobody has explained how the Germans got to Mars, but okay. And then there's this, which some people think proves that there's intelligent life on Mars, but I doubt it. Okay, Mars might or might not have microbial life, and that's true for at least 7 other worlds in our own solar system. Mars, we've talked about. In the news this year has been Venus. Maybe there's some life floating in the clouds of Venus, but there are all these moons of Jupiter and 2 moons of Saturn. All of these places have liquid water or liquid of some sort. On Titan, it's, it looks like liquid natural gas, the same thing you use to cook dinner. But there could be some life in that liquid natural gas. These are all places we could go with our rockets. These are all places where we might find some sort of life. Not life that'll talk back to you, but life that at least shows that biology can arise in many other places. We haven't found any life on any of these places. But if we do, probably in the next 10 or 20 years, if we do, that would be very important, even though it's only microbial, because it would prove that life is not a miracle, that life is just some sort of cosmic infection. It's all over the place. Here's just a diagram giving you some idea of the thousands, more than 4,000 now, planets that have been found to run around other stars. There are a lot of planets out there. In fact, there are more planets out there than there are stars. In our own galaxy, there are like a million planets. That's just one galaxy. Okay. Now, this says 1 in 6 stars is a habitable planet. I should have changed that because recent results suggest that that's much closer to 1 in 2 or 1 in 3. So there are lots of planets out there that could be habitable. And this number is also, probably right now. The number of cousins of our Earth just in the Milky Way is on the order of tens of billions. It's a big number. Okay, so if we think they're out there, and that seems reasonable, not just because of the movies or the television shows you see that show you aliens, we think they're out there, how can we find them? Now, on television, what you do to find the aliens is pretty simple. You just get in a rocket and go. But that really won't work. Our fastest rockets, the fastest rockets, go at about 10 or 15 kilometers per second. Okay? And 10 or 15 kilometers per second means that a trip from Bogota to Medellin wouldn't take very long. It'd be great. But it's not fast enough to go to the stars. To go to the nearest other star at that speed would take you about 75,000 years. And really, that's too long to sit in an airplane or a rocket ship or anything else unless the food was really very good. So here's another way to find the aliens. It's an old idea. It goes back to 1960 when Frank Drake, and here's Frank Drake used this antenna, which is in West Virginia, about a 3-hour drive from Washington, D.C. He used this antenna. He pointed it at a couple of nearby stars, assuming that they might have planets, and tried to listen for radio signals that the aliens might be broadcasting. That idea, in fact, wasn't so new. It went all the way back to people like Marconi and Tesla, but they were pointing their antennas, to the extent they could point them, they were pointing them at Mars. They figured there were Martians. But Frank Drake realized there were no Martians, not with radio transmitters. So he pointed it at a couple of nearby stars. And that was the beginning of the modern search for extraterrestrial intelligence. This is the receiver. This is the radio set that Frank Drake used in 1960. Today, we use much bigger ones, and I'll show you. This is the antenna that we're using at the SETI Institute. It's called the Allen Telescope Array because Paul Allen, who was the co-founder of Microsoft Corporation together with Bill Gates, Paul Allen, who had a lot of money, gave about $40 million to build this array. It was intended to be much bigger with 350 antennas. Well, the money ran out too soon, and we have 42 antennas, but that's still pretty good. Each of these antennas is about 6 meters across. 6 meters across. So if you put this on the roof of your apartment, the neighbors would probably complain, but it's not a very huge radio telescope. This is the receiver that we use, and just a whole lot of modern electronics. We can monitor 72 million channels at once. Okay, that first experiment that Frank Drake did in 1960, he could monitor one channel. And you might say, well, why do you need 72 million? Well, only because we don't know where ET might be broadcasting. Where is his signal on the radio dial? So we try and listen to as much of the dial as we can. Okay, where do we point the telescopes now? Well, as I say, since almost every second star might have a world somewhat like the Earth, you can just point at all the nearby stars and be pretty confident that maybe 50% of them have a planet that might have life, maybe even intelligent life. What we're hoping for is that some of those planets have oceans, right? Not frozen, but liquid oceans, with the right chemicals to do some chemistry, energy, which is to say starlight, and plenty of time. Earth's first life arose maybe 500 million to 1 billion years after the Earth was formed. In other words, very quickly. I know that doesn't sound very quick, but it is pretty quick, right? And then it took another 4 billion years for that life to develop intelligence, right? Like you find on the streets of Bogota. It's a slow process, so you do need time. Okay, well, we haven't found anything so far. Otherwise, my talk wouldn't have been on Saturday. It would have been earlier in this conference if we had found something, and we still haven't. Now, this is Frank again. This is a more recent photo. He also came up with this equation, which we won't talk about because nobody likes to talk about equations. But when I first joined the SETI Institute, which is quite a while ago now, people would come up to Frank at parties and conferences, and they would say, Dr. Drake, when are we going to find the aliens? And I was younger and I was naiver, and I figured that Frank would say something like, who knows? We don't know. But that's not what he said. He said, well, I think it'll be years. He named a number, and everybody connected with the Institute had a number too. Now, I didn't really believe any of those numbers, but I thought I'd try and figure out a number for myself. And this is what I did. This plot here just shows how fast these experiments have been since Frank Drake's first experiment back in 1960. And you can see they're getting faster all the time. In fact, they're getting faster exponentially. This is 2020 over here, and it's 10 billion times faster than Frank's experiment. Well, if you use this plot and you say, okay, I figured 1 in a million star systems might have aliens on some planet there. If you say 1 in a million, I mean, nobody knows. But you say 1 in a million just, to make yourself sound reasonable. If you do that, then we should find ET in the next 15 years or so. So I have bet everybody a cup of coffee that we will find ET before 2035. So here's the thing for you, those of you who are still listening, either we find ET by 2035 or you get a free cup of coffee. So you cannot lose. I hope that's Colombian coffee because that's the best, right? Okay. Now, just a little bit more speculation here about what ET might be like. You might think, who cares? But I bet you do care. Everybody cares. I consult occasionally for Hollywood films, and one of the questions that the producers always ask, what will ET look like? Well, of course, we don't know. We don't know. In the movies, the aliens are usually pretty hostile, and they look like this. They have, sharp teeth. They don't smile much. They don't have any hair, and they have a lot of mucus. I don't know why aliens always have a lot of mucus, but anyhow. All right. Well, will the aliens really look like that or not? Well, we assume that ET is something like us, right? I mean, that they're carbon-based or whatever. So maybe we can figure out what ET is going to be like by considering what we are going to be like when we are more advanced and could be detected by the aliens. In other words, maybe the aliens are just sort of like advanced humans. Well, I don't know what humans are going to look like in the far future, but this particular guy who made these photos thinks he does. This is what humans look like, some of them. Your typical California couple. All right, here they are today. Here was his projection of what they'll look like 20,000 years from now. Now, you might say, I don't see any difference, except their eyes have gotten bigger, right? Their eyes have gotten bigger because they're looking at their cell phones all the time. Okay, probably their fingers have gotten smaller because they have to type on those phones. But that was his prediction. And now, 60,000 years from now, the eyes have gotten even bigger, and none of us is white and none of us is black. Everybody's somewhat in between. Okay, that was his prediction. And then 100,000 years from now, he figures this is what humans will look like. All right, it's going to cost you more to buy a pair of sunglasses, but maybe. So he figures this is what the ETs will look like. But most of the people in Hollywood think this is what the ETs will look like. And sure enough, they have big eyes, right? But they never smile. They don't have any hair. And you might think, oh my gosh, how ugly. But think about it. If this guy moved in to the apartment next door to you, you would probably talk about him for a while, but then eventually you'd invite him over for dinner because actually he doesn't look so different from us, right? I mean, he looks like one of my cousins. He's got 2 eyes and a nose and a mouth. And yeah, okay, the head's a little oddly shaped and he doesn't have much in the way of hair, but a lot of my friends don't have much in the way of hair. So this is what Hollywood figures the aliens will be like, only because he kind of looks like you, right? I don't mean that in an insulting way, but he kind of looks like you, so you can relate to him. You can understand him. He's kind of human-like. But there's no guarantee of that at all. Here's a plot of the size of the human brain over the last 3 million years. Now, 3 million years ago, your brain weighed about 500 grams. If you were, there 3 million years ago. About 1 million years ago, our brains had gotten bigger, and your brain was about 1 kilogram. Today, your brain is about 1.5 kilograms, right? Now, I don't know how many of you weighed your brain this morning, but that's about what it is, 1.5 kilograms. So in the last 1 million years, your brains have gone from 1 kilogram to 1.5 kilograms. And you might say, well, that's not very much. But it makes a big difference, just that last 500 grams, right? Because if you have a brain that's 1 kilogram, you're a forest ape. But if you have a brain that's 1.5 kilograms, you can get tenure at the local university, okay? So there's a big difference between this and that. And we might think that the aliens are just farther up this curve. You know, they have 2-kilogram brains or 10-kilogram brains. Well, maybe, but I think it's more likely that something else will happen. We keep thinking of E.T. as being like us. This is Michelangelo, of course, the Sistine Chapel ceiling, and here you see God, and here you see Adam, and they have some sort of relationship there. All right, but you notice that Adam, that Adam kind of looks like God, or maybe God looks like Adam. Okay, but that would mean that all the aliens would look like Adam too if God made all of them, right? But here's another thought for you. We always imagine the aliens to be biological because we like biology, right? Certainly after age 12, we like biology. But there are problems with biology. To begin with, it's very complex, right? You know that because we still don't have cures for a lot of diseases. Biology is very complex because it's the result of evolution. It's bottom-up engineering, right? Imagine making new cars by taking the existing cars and just dropping them off a building or something and, you know, seeing if any of them got better. Some of them might by accident, but that's no way to build a car. But that's the way biology is built. It's totally, it's the random workings of evolution. We're also very fragile, right? I mean, as somebody pointed out to me, we barely work. And indeed, if you're more than 30 years old, you know that we barely work. It also doesn't improve necessarily. I mean, you know, Julius Caesar was no stupider than the people that, you know, my neighbors here in the Silicon Valley. We haven't changed in 2,000 years. And the other thing is, our lifetimes are very short. You're born, you go to school for 20 years, then you get a job for 40 years, then you retire for a few years, and then they put you in the ground. This is a terrible idea. This is not a good system for intelligence, right? But maybe there's a better way, and the better way is machines. Here's Garry Kasparov, the famous chess player, in 1996, almost 25 years ago, and he was playing against a new IBM computer, and he lost. You can see Gary's not happy about it. And he said afterward, he said it was as if the computer had an alien intelligence. He was thinking it behaved like a brain. Now, mind you, that computer could only play chess, which is, you know, okay, but it's not going to take your job, right? Here's a more recent more recent example of alien intelligence. This is an American TV show called Jeopardy, and these are human contestants, and in the middle, that's an IBM computer. And you can see the IBM computer won, right? A general knowledge competition, and these guys who are pretty good couldn't win against the computer. All right, but still, it's just a game. I mean, you know, you wouldn't want this computer as your roommate, right? It's not human. But look at this. Here's your brain, or something like your brain. And this is how fast your brain works. 10 to the 17th flops. Now, a flop is a floating point operation per second. In other words, you know, multiplying two numbers, or really adding two numbers together that have decimal points. That doesn't matter. That's just an indication of the speed of computers. Now, that's pretty fast, right? That's 1/10 of a billion floating point operations per second. And it all fits into this brain, which fits into your head. But here's a computer, another IBM computer, that's twice as fast as that. Now, this would not fit into your head, right? So it's it's not very convenient. But the point is that machine is already capable of making as many computations per second as your brain. And remember, your brain is mostly doing stuff that you're unaware of. You know, your digestion and breathing and all the things that you just never think about, okay? Well, we already have computers that can do as much computation as that. So things are sort of moving along that direction. And the point is that it won't take very long. Here we are a little over 100 years ago. That's Marconi there, you know, the first radio. He was getting some Morse code on the radio. That was 1900. In 1945, during the Second World War, we had computers. Sure, they were big. They took a whole room. You know, there were a lot of technical problems. They produced a lot of heat, but they worked. And they were very similar to your laptop today in terms of the architecture. So it only took 45 years to go from Marconi to computers. And in another 45 years, we may have strong artificial intelligence. In other words, we may have computers that can write, literature, compose music, produce art, do all the things that you can do with your brain. This is coming. And this may be the most important thing that happens in the 21st century, the development of our successors. Now, if we're going to do this, and you may or may not like it, but if we're going to do this, the aliens, many of them will have already done it. So, biological intelligence seems great, but it's probably not typical. The majority of the intelligence in the cosmos is probably artificial. Okay. Well, one last thing, and then we can go to some questions. People will occasionally ask me, all right, you got these antennas over there in Northern California. These are about 500 kilometers north of San Francisco. I'm speaking to you from about 50 kilometers south of San Francisco in the Silicon Valley, just to give you an indication there. Suppose we find a signal, what happens? Will the U.S. government keep it quiet? People like to suspect the U.S. government of doing all sorts of evil things. And, just to keep people interested, the U.S. government does do a lot of weird stuff. But if we find a signal, would they keep it quiet? And if so, why? Why? Why would they keep it quiet? Everybody would want to know. Well, some people think if the government doesn't keep it quiet, the citizens will riot in the streets. They will go crazy. They will go nonlinear because, after all, there are aliens. Well, ask yourself, right? Is that likely? If you were to read tomorrow in the newspapers or on your phone that scientists had found a signal from aliens, would you say, my God, I'm going to riot in the streets? I doubt it. And besides, these aren't even Americans. These are Canadians. Canadians don't riot very often. Okay, so we're not going to keep it quiet. We can't keep it quiet. In fact, this picture, I made this picture back in 1997. That's a long time now. And this picture was made at 3 a.m. in the morning, right? Most of the world was asleep, but my boss, this guy back here, my boss had called me up and said, you better come down here. We've picked up a signal that looks real. So at 3 o'clock in the morning, all of my colleagues here are watching the computers because we found this signal. Well, it turned out it wasn't ET. It was just a signal from a European satellite. But I can tell you this. About 6 hours after I made this photograph, the New York Times, probably the most important newspaper in the United States, the New York Times called me up to say, hey, you guys are following a signal. Do you think it's real? The news was already out there. There's no secrecy. There's no way to keep it secret. So if we find ET, you will hear about it right away. Just to remind you, there are, as I mentioned, 1 trillion, which is 1 million other planets in our galaxy, and there are 2 million other galaxies, each with 1 million planets. We are among the newest planets in the cosmos. We're just, another ant, if you will, in the backyard, and we should not, restrict ourselves to looking for other ants, because the real intelligence may be, in fact, artificial. Okay, I'm going to stop sharing here and see if there are any questions.
Thank you, Seth. Yes, we have a lot of questions. The first questions is from Samuel from Bogota. If the science has the possibility to create a new Voyager spaceship, what is your message in this new message on the bottle? Personally, Seth Shostak, what is your personal message? Please open the microphone.
Entire talk? No. Okay, is that better? Can you hear me now?
Yes.
Okay. Well, I don't know. There are many things you could ask the aliens. You know, what do you look like? Are you going to kill us all? What? But I would ask them, do you have music? Or maybe I'd ask them, do you have religion? I think one of those two questions.
Ooh, it's a controversial question about their religion.
Well, maybe, but it's kind of interesting to know whether ET also has religion.
Okay. Yes, no more. In 1977, the WOW signal was detected. After 33 years, has it been possible to know more about its origin, about the signal WOW?
Yeah, well, indeed. It has been, 43 years actually, since the WOW signal was found. And many people have looked in that same part of the sky at the same spot on the radio dial to try and find the WOW signal again. And it has never been found again. In fact, the telescope that found it, which was in Ohio, automatically looked again about a minute after it first found the signal and didn't see it. So if you can't find a signal twice, then you have to say, I don't know what it was, but I can't claim that it was ET.
Yes, you are right, 43 years. The next question is for David from Bogota. Human techniques for detecting signals from extraterrestrial civilization are likely to be limited to cover our galaxy. But is there a special habitable zone in which those long-awaited signals can be found?
You mean, is there a, well, does David mean, is there a special part of the galaxy where we can expect signals?
Special, but for civilization, in a special, not for life, in a special high civilization.
Well, I don't think so. But there are people who say, look, there's a part of the galaxy, it's maybe 10 or 20 or 30% of the galaxy, where the motion of the galaxy could cause the production of new heavy stars, and those stars blow up in a supernova, and maybe they wipe out all life nearby. So it could be that there's some parts of the galaxy that are just too dangerous for life. It's like living in downtown Boston. The traffic is so aggressive that it's dangerous to live there. So maybe, or Napoli in Italy, I don't know. But, maybe. But personally, my impression is that life always finds some way to survive. So, but even if it's true, that still leaves the majority of the galaxy open to intelligent life.
Thank you, Seth. If you have the possibility to change the Drake equation or create new equation, what is your new proposal?
Well, many people have wanted to change the Drake equation. Frank Drake tells me he gets emails about every week from people who have suggestions, and he says none of them has been very good. So he's not about to change it. The only thing that you might change is this, and the only thing the Drake equation really doesn't cover is the possibility that life spreads out. In other words, you could have just one planet in the whole galaxy where intelligence arises, it invents machines, and the machines can take themselves somewhere else, right? They could just put rocket engines on the back and go somewhere, right? That sounds odd, but they could do it. So it could be that the Drake equation is wrong only because one intelligent planet might be able to cause the entire galaxy to be colonized, to be civilized.
Thank you, Seth. The last question is, what is the best business in the astrobiology? To find microbial life or civilizations live with high technology?
Well, I'm not sure what best means. There are many, many more people looking for, if you will, microbial life, astrobiology, traditional astrobiology. And I think part of that has to do with the fact that you can send rockets to places like Mars. You're not going to find intelligent life on Mars, but you might find microbial life on Mars. So, there are more things that you can do there. But maybe a more important thing is money. I know the people who are attending this conference probably don't care much about money, but for a SETI to do, to look for intelligent life, you need some money for the telescopes, to pay salaries, whatever. And there is no government funding of SETI at all, not in this country. There really isn't. So that's a problem. In terms of a career, you'll have many more chances in astrobiology than in SETI. However, having said that, what would you rather find? Microbes on Mars or Klingons or some other intelligent aliens?
Now, this is the last question from Marcelo from Argentina. Dear Seth, oh my God, Graham has the last question. Dear Seth, when do you think we will receive the first radio signal from some extraterrestrial civilization?
Yeah, well, Marcelo, I actually mentioned this in my talk, that I have bet you a cup of Colombian coffee, or Starbucks, if you would prefer that, but I don't know why you would, that we will find a signal from ET by 2036. In other words, another 15 years. And if not, you get a cup of coffee.
Yes, it's a promise.
Yeah, if I'm alive, but yes.
But the first coffee will be in Colombia, right?
Well, if if the first claim is in Colombia.
Okay, Seth, thank you so much again for sharing your knowledge with us. And Colombia is your second home.
Well, I appreciate that. I had great memories of coming to Bogota.
Yes, me too, on my team too. Thank you so much, and welcome again to this astrobiology conference. Bye.
Bye-bye.
Bye. Thank you.